In our journey through quantum science, we have already seen nature break classical certainty. Light refused to remain only a wave, energy refused to flow continuously, and the universe imposed a limit on how precisely motion and position cannot be known together. These were not isolated discoveries, but signals that reality at its core is built differently. That deeper structure reveals itself in one central idea, the quantum superposition. In the classical world, a system must be in one definite state. A switch is on or off, a bit is 0 or 1, a coin is heads or tails. But quantum mechanics makes a sharper claim. If a system can be in a state of get 0 and if it can be in the state of get 1, then it can also exist in a combination of both. That is, get psi is equal to alpha into get 0 plus beta into get 1. This is superposition. Here, alpha and beta are complex numbers called probability amplitudes. They obey one strict rule. Modulus of alpha square plus modulus of beta square is equal to 1, which simply means total probability equals 100%. When we measure, probability of 0 is equal to modulus of alpha square and probability of 1 is equal to modulus of beta square. But before measurement, it is not 0, it is not 1. It is one coherent quantum state that mathematically contains both possibilities. That is not philosophy, that is linear algebra. Now, here is the crucial bridge to computing. In a quantum computer, classical input data, the numbers, problems, search conditions, are first encoded into quantum states. This encoding prepares qubits into specific wave functions like the one you just saw. The quantum processors then evolves these wave functions using controlled operations. At the end, the measurement converts the quantum state back into classical bits, the results that a classical computer can read. So the beginning and the end are classical. The transformation in between is quantum. Now comes the real power. Possibilities alone do nothing. The engine of quantum advantage is interference. When two amplitudes combine, say A and B, the probability becomes this. The final term 2 into modulus of A modulus of B cos theta is interference. If phases align, constructive interference. If phases oppose, destructive interference. Quantum algorithms manipulate this phase angle theta. Wrong answers cancel, correct answers reinforce. This is how probability is reshaped. Not magic, but phase engineering. But it is important to remain scientifically grounded. Quantum computers are not replacement for classical computers. They are not designed to browse the internet, edit videos, or run everyday softwares. For most tasks, arithmetic, data storage, graphics, operating systems, classical computers are far more superior and more stable and dramatically more efficient. Quantum computers show advantage only in certain vast and specific problems such as large number factorization, quantum simulation, and structured searches. They are specialized instruments, not universal upgrades of regular computers. All of this depends on one fragile requirement, the coherence. Every interaction with the environment, heat, light, vibration, tries to disturb phase relationships. When those phases are lost, interference disappears. This is called decoherence. No observer is required, no consciousness is involved, interaction alone is enough. This is why quantum computers operate near absolute zero to protect coherence long enough for interference to complete its work. Superposition unifies everything we have discussed: wave particle duality, quantization, uncertainty. It is not an isolated idea, it is the mathematical backbone of quantum theory. If reality fundamentally evolves as a structured superposition of possibilities, then certainty is not fundamental right. It emerges, and if we learn to control superposition and interference, we are not just building new machines, we are learning to engineer fundamental theory of existence itself. In the coming days, we will explore quantum entanglement, tunneling, and deeper non classical correlations that push the limits of locality and consciousness. Quantum physics is not a finished theory, it is an open frontier. To the young minds watching, this field is waiting for you. Let's stay superpositioned with the uncertainties classical physics holds and the exponential discoveries quantum physics has in it. Don't forget your formalities to our channel. Nandri, Vanakkam.
Innovate to sustain.